setup Go, setup Java. And they're all written,
go ahead.
they're all like, oh, the Java, the setup Java, the install script is a 1.2 megabyte .js file. Which I thought was interesting design decision.
I mean, this is like, it comes down to like, unless you really understand how BATS works, like testability becomes the issue with trying to do, because like clearly setup Java would be better done in Bash, but it just doesn't have the same level of testability that Node does.
Yeah, I mean, that's true, but I also feel like a lot of those things that are better at Bash tend to be like side effects as a service. Like we struggled with that in the build pack too, where it's like, how do I test this aside from just running Maven, you know?
Yeah.
And so I don't know. Sometimes it's just a hard problem, I guess.
That's a good phrasing. Side effects as a service. I like that.
That made my day. That you like that.
Are we doing stack packs today?
No, we're just gonna rip on Go for a while.
Okay. I should probably drop off then. I don't know if I.
Yeah, I'm gonna share in a second.
We would like to do something before you do that.
Okay.
Which we think is somewhat related. Which is talk about CA certificates. So we think we've come up, I mentioned this at the other working group, with the solution, like we wrote a build pack that can install CA certificates at build and runtime that doesn't need root privileges. And while this is a Paketo build pack we wrote, I feel like it's relevant to the group because if the CA certificates are not an important use case for stack packs out of the gate, I feel like they introduce certain types of complexity that could be cut out for later. So things like even recovering the entire build plan, right? If the only thing we were doing was mix-ins in the stack pack, all you would need is the delta of mix-ins to rerun something during rebase. And things like providing that platform directory during rebase and stuff like that. So like whether or not CA certs could be robustly solved without stack packs, I think could change how we want to prioritize some of those features of stack packs.
I guess.
Yeah.
Sorry.
What do you want to
finish?
Go for it. Well, I want to demo it, but go ahead, Stephen.
Makes sense. I'm the CA cert build pack sets some environment variables that OpenSSL respects, right? So that applications that use OpenSSL and versions that support that library, in many cases can use them. But we did some experiments with those, like admittedly quite a long time ago, and found that a lot of things don't, or at least a couple things we saw didn't respect them to the point where it, like for whatever reason, we put that down and said it's important that we be able to install CA certs in the OS cert store. I haven't seen anything that doesn't work with it now, and so it's like I'm not saying I think this isn't a solution that is complete. I'm just saying I worry that it's it feels early to say, oh, we solved the problem, and then skip adding support for it when there are probably things there may be things that may look for CA certs directly. A lot of different languages have language modules, for instance, that parse CA certs directly and don't use OpenSSL.
Yeah, but like those are incredibly rare to like none of the languages that the people on this call actually care about. Java would be the big exception. And it turns out that writing the shim to link Java to the same environment variables is trivial to do. And so like one of the things that has bugged me, obviously, it has bugged me so much, I came to the Thursday meeting. So like take this as an indication of how I feel about this, is that because we so tightly tied this, and like this is sort of a broader thing that I want us to think about. We needed a surgical fix 9 months ago, support for CA certs at build and runtime. But because we tied it to something like stack packs that would take so long to land, and we added additional complexity to stack packs, making it harder to land, that like we missed the point. Like I really, if we hadn't sort of tied it, would Emily have noticed these environment variables 6 months ago, and we would have had it this whole time? Like that's the key thing is we can deliver for the vast majority of users the functionality they've actually been looking for in this way. And until someone comes to us and says, hey, I'm running R and this doesn't work, but except I'm pretty sure R does do this. Like, why did it have to be more complex than this?
Also, like we have it working against samples with Node, Java, Go, and you can also use curl, which doesn't use OpenSSL, respects these environment variables. I wonder if maybe some of the early experiments into this didn't complete all of the steps that would happen if you did an update CA certs on your machine, which now we've replicated, sort of computing the cert subject hash and creating symlinks is a thing that libraries then use when they're going to look up certificates in a directory. And if that wasn't computed and the links weren't created, I feel like that could have stopped some of the integrations from working, right?
And Emily is happy to tell you, it's harder than you think to actually do that computation. It's not documented very well at all.
So I actually feel like I was saying that we could probably pull off CA certs without stack packs a while ago. So I'm very much support trying to find a way. I also think it's really healthy to have multiple solutions to this problem, especially like, even if we think there's like edge cases for a particular solution, eventually delivering stack packs as a more blanket solution seems totally fine. And if maybe not even just fine, but fantastic, right? Like a stack that does not want to support stack Buildpacks would need an alternative solution. So I mean, I like the direction it's going is all I'm saying.
So I'm sorry I was late to this, but could we maybe reiterate exactly what it is that we're discussing very briefly?
We're discussing a non-stack pack solution for CA certs. We believe we're able to solve it fairly robustly without stack packs in a regular build pack. And I can demo this. I have some apps working with that if we feel like there's a good use of time and work group. Yeah.
Yeah, because I know like I'll take, the responsibility that's due to myself in some of the research and trying to get this in initially. And I brought up some of the concerns that it seems like we're talking about right now, right? Like when we have the CA certs single file versus all the different hashed symlinks essentially, and how that works with the Docker VM. And I created a blog post, which, never really posted because it essentially the ground slightly kept moving from time to time. And it seemed like it didn't satisfy still 100% of the cases, right? So all that seemed like patchwork, not so much something that was a robust implementation. So Emily, does it sound like you're saying that there's a very different strategy that you've come across to solve it?
Yeah, so I think the impression we were under before was that, how in the VM, there's like a directory with a bunch of certs and a bunch of hash symlink pointing at the certs. And there's also one giant cert file. I think we were under the impression we would have to update the giant cert file with our cert to make everything work. But it seems like there are two ways to configure OpenSSL and a variety of other tools with different crypto libraries. They all seem to support these environment variables, where you can set both the cert file and the cert directory. And not only that, but the cert directory can be sort of a bunch of path locations, sort of like a path environment variable. So a build pack could, at build time and also at runtime, just create one additional location for certs and append this directory to the SSL certs cert dir environment variable. And then the certs will be respected by all of the tools. So you don't actually have to go update the canonical certs dir or file, which makes things simpler because then it's all in a normal layer, right?
Right. Yeah, that's definitely something I didn't find. And yeah, I mean, I wasn't the only one, so I hope it's not too frowned upon. But yeah, this is
no, like this is
interesting.
not
Yeah.
documented at all. Well,
But we have found like other places that were relying on this. Like Ben had a link to like a Go issue where they're using the fact that this works, right?
I'm not convinced that everything uses the same interface widely enough for it to be a complete solution. But at the same time, stack packs are intended to be a per app use case for CA certs, right? Or like a way to install CA certs for a single app, not like a way to extend a base image to have CA certs in it. And the use cases I have for CA certs are around extending a base image with CA certs. So solving a CA cert problem for stack packs, although I'm not fully convinced that the normal Buildpack solution for it in a per app basis works in all cases, I'm actually not very attached to needing to solve CA certs in the stack pack case specifically, if that makes sense.
I do think some, like I know Signo is probably interested in a stack pack type solution for CA certs because they just want it probably on the image and be able to run it that way.
that doesn't require stack packs though, right? Imagine if you wrote a Docker file that knew how to take a base image and add another CA cert to a base image. Is that sufficient?
I think they just don't want to have to manage Docker files for that.
I think we could do that
Versus
with Buildpack
managing a
as well,
stack
right?
pack where you define the exact same things.
Like I feel like a build pack solution is very much like a stack pack solution, except it doesn't require root privileges, right? So if that works, it works.
And it sounds like that this, if we're talking about it as a build pack, is a very independent solution that isn't, attached to anything at all, right? Like it's not even a pack implementation necessarily. It's just Pacato releases something that does this thing. The Heroku builder includes the same sort of build pack or their implementation of it.
Yeah, exactly. So I can show you how this works now. We've made a decision that at runtime, we're still supplying the certs at the last minute with a binding, but this would work just as well if you baked them in at build time. So I've created I have a server running that requires a CA that I've signed to connect to. And I have some sample applications here. Let's do the Go one here for a second. So I'm going to build this sample. Sorry, I forgot to change the path. Don't want to replace my Go one with Java. Here we go. Okay, so I'm building a Go application. All it does is basically accepts a single positional argument and curls that endpoint. So this first example isn't using CA certs at build time. It's a runtime example, but we could do a build time example as well. And what the CA cert build pack does is it contributes a helper that, like a profile D helper, but eventually could be an exec D helper once we support that. That will then look for a CA cert binding and add the trusted certs at runtime. So first, let's do this without the binding. So I have this endpoint that I need a certificate to hit here. And you can see that I'm getting a certificate error. But in my bindings directory here, I have a CA certificate type binding that includes the CA certificate. So now, because of this helper we've installed, if we rerun this with a volume mount, profile D script then sets these environment variables we're talking about and creates a temp directory on the fly with the correct symlinks in it. And then we can hit the endpoint. And we have examples where we can run this for Node and Java as well. A build time example had to be a little bit more contrived because I was too lazy to like create an actual build time dependency that was, like a node module server on my custom endpoint here. But I have a build pack that just tries to curl something at build time. So let's say I was going to build this node application. And I can give it an endpoint that it wants to curl during build. We can make this our sample example here. And you can see this is using curl, which doesn't use OpenSSL actually, but it's trying to connect and it's refused. But if we use the pack volume flag to provide a binding again, and this is the exact same binding that we're using at runtime. Then this build pack, you can see it's doing a little bit more this time because it's found the certificate binding. So it's creating a layer that has this cert in it, and it's setting these environment variables. It failed. Hold on. This was definitely working earlier. MVP test
The environment variable. Oh no, actually no, it's not right either.
Well, it's a bad example, I guess, if it's not working, but I promise you it was working earlier. I think I must have screwed something up. I should have kept my history here. Hold on. Let me check the binding.
While you're looking for that, I have a question. It's not really relevant to what I'm doing, but do we know that Windows will not require admin to do the same sort of certificate stuff?
If the same environment variables are respected and therefore we can modify whatever file system location we want, then I don't see why we would need admin, right? All we need is permissions to create a normal directory and then set a couple environment variables.
I don't think these are OpenSSL. I don't think the format for CA certs in Windows, uses OpenSSL or things like that. So it seems like a really big if. Doesn't Windows have a special cert, management thing?
Yeah, it's probably all
Windows might be its own thing.
Yeah, but I wondered if it requires admin. That sort of, if we knew that adding new certs to Windows for like doing PowerShell installs from like remote PowerShell, repos or something required root or required admin, then that would weaken this argument that, I don't care like about Windows myself right now, but just wondering if we've done that research.
I haven't. I've punted on the Windows thing. I'm going to stop trying to make this work right now. I'll get it to work and then get back to you because it definitely was working earlier, but I feel like I'm not going to debug this.
I think we can believe you that it worked at some point.
Yeah.
It's fine. I think so there was an original statement I think you made, Emily, about why you're demoing or talking about CA certs as a regular build pack, and that was to simplify stack packs. Is that correct? Or I think I may have gotten lost in the shuffle of the discussions about the CA cert build pack in general, maybe.
I also figured out what was wrong with that. I had to put it on the host network so I could talk to the endpoint. But yeah,
like what? I guess like what are you looking to get? Like this is really cool and this is awesome, but what are you looking to get out of this working group discussion with these people about this?
I guess I'm not even trying to cut the final scope for stack packs at all. I'm just trying to, because one of the problems we've had getting this through is the complexity, right? And I think a mix-ins only solution reduces some complexity because you don't need to necessarily have platform available at rebase time. You don't need the full build plan available at rebase time, you could just use sort of the diff of mixins between the run image and the app image. And I'm wondering if by cutting out a more complicated use case that we're trying to support on the first pass would give us a vertical slice that'd be easier to move forward on.
What would we try to cut concretely? Do we know? Like what piece of this do you think we should cut if we thought that this was a path?
I think we don't need to worry about storing the entire build plan. And especially if that build plan includes, like, let's say we installed CA certs the first time and then you're redoing them the second time. Like maybe that plan had paths to certs in it, and those paths are actually different when you're running on rebase because they weren't baked into the image. They're provided in an arbitrary binding or something like that. I feel like there's edge cases there when you're talking about arbitrary things and metadata and state that existed at build time that you need to recreate to do a rebase correctly. And I think because of the way we define mixins, if you're talking about just mixins, it's simpler, right? Because the name itself captures all the data you need.
I mean, it is simpler. I would worry that it's too simple. Part of the reason that we went the direction of having a more generic mechanism than like the original, like I forget what it was, like extend binary or something that would run on the builder. The thing that Stephen originally proposed. Part of the reason we went with a more generic solution was like the conversations we had with, I can't remember if I can say or not, but like two companies that I think that were pretty well known that we both talked to that had teams maintaining base images that wanted to provide like custom binaries that various teams in their organization could have installed. Like, I can't remember some of the specific examples, but it was basically like, yeah, we have this like security scanning binary that needs to be installed with root privileges, but they want the like app developer to opt in. And so the CA cert build pack example that was in my RFC is kind of meant to be like a more like to illustrate that kind of thing where you have, it's not a mixin, and you have like a build pack that triggers the stack pack. So I kind of feel like that's still an important enough use case that we should try to incorporate it. If we were to exclude that case to where it was truly just mixins, there's a little bit of a slippery slope there where we could actually get rid of detect. We could really remove a lot. We could actually remove too much to where it might be hard to figure out how to add those things in later. So I guess what I'm saying is I worry a little bit about just chopping that part out.
Yeah, I guess I was hoping that we were in a sweet spot where we had gone far enough down the path of what it would look like to add those things later that we know our solution doesn't preclude it, but it would allow us to ship something much simpler by cutting it down, right? That's the proposition, I guess.
Getting the RFC approved with the more general build plan functionality, though, doesn't prevent us from shipping the mixin part and speccing the mixin part before the other parts are specced, right? I worry that if we like had built a bunch of abstraction in the current RFC that was just intended for CA certs and was clearly really specific to that use case, and we discovered that we can probably push off the per app, installing stuff into the OS cert store proper problem for longer because it's like, not as big of a problem for a lot of types of apps. I'd be supportive of cutting that CA cert specific functionality out, but I don't see a lot of stuff in the current RFC that looks like it was just designed for CA certs. To me, that was just kind of like an example of a type of change that's not a package change, and the thing we designed to support it is like a generic way of representing things that can be provided on the base image that other build packs can require, and not like something that's very tailored for CA certs. But I could be wrong. It might be really tailored for CA certs, and I just
I think the only thing that's super tailored is like the fact that we want the platform directory at rebase.
We want the platform directory at rebase?
Well, you need to with CA certs, right? If you're binding them in.
For which? For stack packs?
Yes. Because you'd be
Yeah, 'cause when you
rerunning
extend
those
it,
changes. Yeah.
you've gotta have it when you re-extend, basically. I don't even know if the RFC says that.
That's
but yeah.
assuming a particular implementation of how CA certs work though, right?
It's true. Yeah, your example I think isn't the bin or the
Right.
detect or something. You just like pass the cert over or something or reading
Yeah,
a
you
file
put it in the
from.
build plan.
I guess they're present during extend, and therefore they have to be to perform the same operation again. You'd have to like snapshot the platform dir and the image labels or something crazy.
Yeah, I feel like if we don't want to give the platform directory during rebase, we shouldn't give it during extend. And we definitely are in the current RFC. Because there'd be no way to rerun arbitrarily whatever happened without that, right?
Should we cut it during extend? That's the change.
I think that makes sense to me. On some level, I suspect, like, I wonder if we're going to end up in a world where the only stack packs are doing mix-ins, realistically, but
I don't think so. And I mean, if it helps, I can change the CA cert example to be more along the lines of those like proprietary like the security scanning binaries example.
Yeah, I'd like to see an example that uses like, requires provides with metadata that isn't CA certs as well, like a real world sort of example. That would be nice to have. Because yeah, persisting the build plans definitely is complexity that we wouldn't have to take on if we didn't have to. That'd be kind of nice. But yeah, if we don't mount the platform during rebase, but we do it during build, that sort of, does that mean like all your build invars? I don't know. Like, that could get weird too if we don't do it. We kind of have to do it everywhere, or yeah, I feel like.
When you say persisting the build plan, you mean persisting the build pack plan fed into each stack pack, but just the extend one, right?
Yes, yeah, you have to persist the build pack plan for extend for rebase.
I hadn't even thought about environment variables in the platform dir, but that's also a thing, right?
Yeah.
You probably shouldn't have a build pack that is configured with environment variables unless you're then providing the platform dir everywhere you'd need to run it.
Yeah, I think you pretty much would have to. I think I'd probably have to run that for our platform anyway. Like, if you've got like keys to contact some artifactory, something or another, you may still need to do that with rebase anyway.
I'm not saying we have to change anything about the stack pack stuff. I just want to throw this out there. Like, if we were making our lives harder, maybe this could make it easier. But if no one wants to do it, it's fun.
So wait, you're saying for the platform dir at extend in the extend phase? I'm not sure I had that same assumption, or at least I wasn't necessarily thinking that like an environment variable that you pass to the build phase would be exposed in the extend phase, which would also solve that problem if you just don't allow that.
If we don't provide platform during extend, that's how we provide environment variables right now. So first of all, your stack packs can't accept environment variables, which is maybe a fine limitation.
Yeah, Joe, what I'm thinking concretely is like ESM or something like that, where like you want to provide some key or something that is that you need on rebase to like get these sources there.
We are missing. I don't think the RFC covers environment variables in any case, right? We don't say that they're going to be available during build or extend, just at all.
In some ways, that feels more dangerous to me because things could. Well, if it's not available during rebase, I definitely don't want it to be there during extend because I think people will break something.
Yeah.
If it's not available during extend, though, it probably shouldn't be available during build because you're talking about the same build pack running on slightly different images, but one gets the environment and the other doesn't. That seems really confusing for stack pack authors.
Yeah, which is then hard. Like, how do we stop stack packs from reading a platform dir if it's provided during build? I guess we should change the build pack interface at least so it doesn't receive the platform dir as an argument, which it currently does, right? The stack pack.
But Joe, does that make stack packs look not enough like
And they could
Buildpacks
also
and
pass a
like-
different platform dir, like a empty one or something.
Is that going to be tricky with the builder and the?
I guess would the point of that is only just to keep the arity the same? Like, does that? It seems more confusing to pass an empty dir.
Well, it might be more like, I don't know. I'd have to think about it more. I'm thinking exclusively about nvars right now, but like there might be other cases where it does make sense to have like something in there that is different. I don't know. I guess I'm not. I'd have to think more about the difference between extend and build phase, whether like how jarring that is if they didn't have the platform dir for extend but did have it for build.
Have an alternative, which is we could provide the platform dir for build and extend, and then we could just store the environment variables that we set, or like that were set in the image somewhere, and then on rebase recover those same environment variables, because we don't actually want to change the environment variables on rebase anyways. We want them to be the same values they were originally because it's a rebase. So I don't think we actually want the platform dir on rebase. I think we want the old platform dir from the extend phase, as it was when that extend happened, when rebase was played. So I don't know if this is the same problem we think it is. I think it may just be we need to store the values of the environment variables that got set during extend and recover them in the environment, potentially, and rebase.
I think that could get really weird if you have secrets like Artifactory and stuff like those need to rotate. Maybe you set them in your platform and you rebase a year later your Artifactory credentials that are stored at the platform level. Those do have to rotate and stuff like that.
But
it has
do
to
you
be
want
a
them-
different level of sensitivity to how we're treating things right now, right? Like theoretically a platform that's putting things in a binding might be surprised that they end up then hard-coded into the image. Like you'd want to be very careful about telling people that like the environment variables in the platform directory are treated very differently than the bindings, like what is and what isn't secret.
Maybe we need a third phase that's different from extend. The build pack can put different code. The first extend means a thing that runs with the platform dir, and subsequent extends mean, I don't know. It doesn't work too well though, because then you're trying to apply the same types of changes.
Or we could just do mixins for now, keep things simple, and then build on it later.
I think mixins have the same problem though, because what if you want to pass environment variables to apt, right, or something like that?
I feel like I'd rather disallow more and then allow later. So it's not so complex that we can't get it done.
So you would cut environment variables from stack packs entirely.
Yeah.
But I think that's separate from whether stack packs support more than mixins, right? Or to me, that's an orthogonal thing.
Yeah.
How do you configure stack packs? Are we saying that they're not configurable then? If it's not their environment variables?
Build plan. I mean, that's sort of the proposal with the CA cert example is something like a secondary build pack would, maybe we should get into the RC, but the example that's in the RC is a sort of secondary user space build pack requires CA cert, and then in the metadata can provide like the path to the cert or the actual cert itself. But they also have access to the apt or at detect, so they could potentially read configuration at that point.
I think the short-term goal we want to get to is some consensus on stack packs, right? On that stack pack RFC to be able to get that in.
I mean, I'm okay with not having nvars at all phases. I think that's fine. And potentially adding them later if we come up with a solution.
I was going to ask, from what we have now, what are the things that people feel they would have to change in order to get this approved? And the one thing that I can identify so far is we need to make some decision on environment variables, right? But does anybody feel like we need to cut the build plan entry, that they're uncomfortable with the non-mix-in build plan entries, or should we keep that in for now?
I feel like I want to cut the whole platform dir.
On the nvar thing for, yeah, sorry.
Well, not just nvars, but
Like they can't load anything in, right?
yeah, they can't get anything to the platform.
To solve the
So
nvar
basically
thing.
saying,
Sure.
yeah,
But
Right, and the
anything else
binding
that-
thing and
yeah,
the
even
whatever
binding.
the platform specific integration that it built in the place we told it to thing is.
Do you want to cut them during both build and extend? Or would you cut platform during both build and extend?
I feel like you have to cut it during extend. In my mind, that also makes sense to cut it during build, but that doesn't feel like it's hard of a line.
It'd be pretty weird if you provide an argument to apt or via an environment variable and it works in one image and it doesn't work in the other image, right? So I guess, Joe, we cut the platform dir from build and extend for stack packs and left in the, non-mix-in build plan entries parts. How would you feel about that?
Sorry, can you state that again?
If the only change to the current RFC were cutting the platform directory from stack pack build and extend, but we left non-mix-in build plan entries intact. How would you feel about that?
Yeah, I would frame it as just passing a different platform directory that is potentially empty. But,
I think that's or
What's the purpose of that?
I'll let Emily.
just to keep the interface the same.
What are we really? Why? Like, why is keeping the number of positional arguments the same an important thing to do?
Well, for one, I think it's one less thing people need to think about if they're authoring a stack pack. The other is it gives us a little wiggle room in the future to use a stack platform directory as a thing, instead of having to like figure out what to do with it later. Like if we run into a situation where we need something specific to stack packs, that could be provided in that way. I mean, I don't have an example, but
The platform directory, basically everything in the platform directory kind of breaks rebase, because in a rebase you really don't want anything to change besides the base image, right, and packages on the base image. And so as soon as you add a platform dir and extend, the platform dir kind of needs to be there in the rebase case. Like it kind of all just collapses down to like, I think rebase makes platform dir for stack packs anywhere kind of problematic, or like any kind of value that can vary on different builds, right? Because you don't want it to vary in the rebase case.
Completely an aside, but wasn't there a thought of potentially getting rid of positional arguments in favor of environment variables only?
Not for this RFC.
Right. But I'm saying like that was a thing, right? So are we
Yes.
just kind of at that pain point right now because of it?
Well, I mean, actually, in the case of platform dir, it's the last directory, and so there's no, enforcement of the, positional arguments you're passing into a script, so it doesn't really matter. It's like the question is, should we tell Buildpack authors that they can rely on argv3 or whatever existing in stack packs?
I think it's fine to not give them give stack packs the platform dir. I need to think about it more.
I'm just thinking like, I know we use like, we log into ESM for our updates for like older stacks and stuff like that. Is that going to be, I don't know, is that,
Yeah, no, yeah,
nowhere a stack pack would ever need to do something like that without having an invar?
yeah, no, I can think of private repositories that you need to pull artifacts from.
Make a build pack that requires a thing, and then it gets sent. And then the build plan will be captured in the build plan that then gets sent to.
It gets
extend
persisted
Yeah.
in the extend. Yeah.
Yeah, I know about secrets in a build plan. Sounds
yeah.
bad.
Yeah, because you're talking about a potentially platform-specific secret being stored in a build plan in that case.
So going back to configuring it via, let's say, the app source directory, you could have a file there, right? And then exclude it from being persisted as a workaround. It doesn't seem like something nice to have to do.
But then you wouldn't have the same configuration.
But that's kind of
Yeah.
what they want, right? Is they don't want the same configuration for this particular case, because it's secrets that may change from, you know, time A to time B.
Yeah.
Yeah, in that case, you just have to have the platform mounted at rebase, essentially, right? It's the
Exactly. Yeah. I feel like it's easier to go the other way and just always have it mounted, but I know that presents its own challenges.
I mean, maybe we just always mount it everywhere and then let it just be inconsistent between different builds and hope that everything is okay.
I'll
We kind
definitely
of do that with invars anyway, with reproducibility a little bit, right? Like invars are sort of out of the scope of that.
Yeah.
But not with
Mhm.
rebase.
makes a rebase a lot more like a rebuild, right? Like if we do this, I'm not going to rebase my app and then just deploy it to prod.
Well, you could warn
mean-
when there's more stuff. I guess the problem is
Yeah.
that it's going to be mixed. It's mixing the environment variables intended for stack packs with the environment variables intended for all the other tools, and that's maybe a problem.
I feel like there's plenty of ways for rebase to be different depending on when and where you ran it, whether it's a URL that the artifact at the other end changed or some other thing. And this is at least one that is determined by the person running the rebase operation rather than the stack pack author.
I think the problem is that stack packs are just intended to make ABI compatible changes. And if the environment were a separate environment that were just intended for stack packs that just affected those stack packs and was configuration that's along the lines of making those stack packs make ABI compatible changes, that would be okay, even if it varied, because you could just continue to stipulate, it has to be safe. But if you mix the other build pack environment variables into those environment variables and they vary between rebase and build, then you really could have, materially something could happen, right, where you get configuration in the environment of the stack pack that's different at rebase and causes a different behavior. It no longer isolates the rebase case to changes that are safe to apply.
So what if there was a mechanism that not necessarily restricted, but more or less supported or helped the use case by not storing the exact values, but let's say just listing the contents of the platform dir and then making that same check again during rebase. And if there's a difference, then, essentially failing with a force flag if they really wanted to continue forward.
The problem is the other build pack environment variables. Anytime any build pack needs environment variables for configuration, it's always going to be different on rebase, right? So if you're building a Go app and you say, here are my Go targets on build, you're not going to supply those on rebase. And so now stack packs don't work for all Go apps, right? And for Potato, we're moving to environment variables for configuration for everything. So it basically would mean stack packs just don't work with build packs. Or like it would always, the case you're talking about where they're mismatched would always be true, or nearly always be true.
Yeah, I was supposed to say, yeah, because even if you're just reading non-platform invars today to make decisions, that's gonna potentially produce a different result, right?
So I think we got a problem with the platform there. We don't have a great solution to.
Even not the platform though, right? Couldn't you get a base image update that has a different invar value that you're relying on?
I think Joe made a good point that rebase is just never safe with stack packs now. It's almost like you'd want a different it's a small version of
It's-
rebuild, but like anything
It's
could
dependent.
happen. Yeah.
No, I
It's
disagree.
dependent on the stack pack author.
Yeah, the stack pack author could be crawling something from a URL, like Joe said, that what's that URL changed, and you don't know for sure. Like it's trying to apply ABI compatible changes, but you have to have a lot of trust.
But the stack pack author is the same person who makes new run images, right? So saying that is the same thing as saying the person who makes new run images could ship a new run image that's actually Ubuntu 20.04 instead of 18.04, right? The reason why we put stack packs in the domain of the stack author is it's the stack author's responsibility to enforce ABI compatibility. This goes further than the stack author because it allows build pack configuration that the user supplies into that environment of the stack pack.
But it's the stack pack author's choice to accept those, right? Like you don't have to source the env, you don't have to do anything with an environment variable as a stack pack author.
It's true, but it makes the stack pack author's job pretty hard because if they don't pass clear env, everything in the environment's going to be set, and the environment's, you know, they have no way of ensuring that the environment, or without going through some serious hoops, right? Like setting that special flag in Buildpack toml, you know, they're going to end up, they're not going to easily be able to enforce that the environment doesn't change. And maybe that's okay, but I would want us to say it's okay. We're going to accept that that's a limitation, but we are going to assume that stack pack authors are able to do the right thing and ensure that stack pack changes are ABI compatible and that rebase is still safe.
Like, yes, you're right that this was always on the stack pack author who created the run image. I just think the more moving parts there are, the bigger the foot gun is, right? The more mistakes you could possibly make that make this, that make you not want to trust a rebase.
In the generic case though, right? Or in like the case that we care about for operating system packages, right? It really is always safe. It's going to be a tool for installing, you know, updated versions of, you know, Ubuntu 18.04 LTS packages that have strong guarantees about their changes, or the same guarantees that we're providing for the run image, right? So in most cases, it is safe, and we do get those guarantees in there. So it seems like platform dir is a problem. I don't know if we're going to come up with a solution to platform dir immediately. What else? I know we only have 4 minutes left. Are there other outstanding things in stack packs that we've identified?
No, I'm really sorry I derailed this. I feel like it's not that I'm trying to slow this down. I just have existential anxiety that like the stack packs are going to, that we're going to cause problems for ourselves, right? And sort of limiting the surface area.
In the same way that we, sorry, let me throw something out. If we, in the same way that we split root build packs into potentially root build packs and stack packs, could we split stack packs into potentially stack packs and mix-in packs? Where the difference would be that a mix-in build pack does ensure, it does have certain guarantees that a stack pack that is not a mix-in build pack would not necessarily have, such that you could, as a stack provider, include mix-in stack packs and not other stack packs?
I think a stack pack is already supposed to be that. And I think that there aren't actually strong differences between those two things, because you may still need credentials in the environment to reach out to a separate repository of LTS 1804 Ubuntu packages because you're in an air-gapped environment, right? Or something like that.
Yeah.
Like
yeah.
I wouldn't say Mix and Buildpacks don't need that kind of configuration. This is why I haven't proposed a solution to this yet, right? And the other thing is that I think root Buildpacks really are that because we've gone through the effort of designing this API where we're going to do this operation and do a rebase, right, where the rest of the stuff on top doesn't have to be rebuilt, which relies on ABI compatibility. The compatibility guarantee of a mix-in pack and a stack pack would actually be the same. And when you lose that compatibility, we shouldn't do rebase anymore, and that's what a root build pack is. And so I'm pretty happy with how we've scoped stack packs, except for we have this configuration problem.
Right?
Yeah,
let me try and state that back to you, because I think I understand. I think what you're saying is, in that sort of split that I was describing, if there was such a thing as stack pack that is not a mix and build pack, that we probably shouldn't allow rebase for that other class anyways. Right. And so for that reason, that makes sense.
If we're going to allow rebase, take already built code and swap what's under it. The things that under it can't really be allowed to change anything besides LTS, or like besides dynamic libraries that are, have not changed their layout in memory, right?
Besides mixins.
Sorry.
I said besides the things that mostly would end up being given a name as a mix-in, right?
You can have other changes that aren't mix-ins, right? Which are Ubuntu packages for IO, Buildpacks, Stacks, Bionic, but are still installed and still don't affect the API compatibility of the image, like build tools, right? Or libraries that aren't LTS, that aren't coming from Canonical, but still get security patches. ESM Ubuntu packages, maybe a good example. And an example that also requires credentials.
This weirdly feels kind of like Docker credential helpers now to me for mix-in installation. Like it's just a much simpler interface when you're just talking about mix-ins. Like they would know about platform-specific places to fetch environment variables to do things like log into ESM repositories to do its job. That doesn't have to be so open-ended. It doesn't have to be the platform dir. It can change. And I know it could still produce different results, but I don't know, it just feels more tightly controlled.
Maybe we just need to introduce a third set of environment variables called stack environment variables. Stack env, and that has to be the same. And then maybe that comes in platform env during stack packs and just follows the same convention. And then we keep the arity of the method. We have different environment variables for stacks. Those environment variables you have to guarantee are the same. Does that just solve everything?
I think that's kind of what I was trying to describe as an alternative platform directory for stack packs.
Anybody hate that?
Explicitly platform specific or whatever.
They'll run into the same problems, right? About how do you ensure that this is the exact same thing that you pass at the first time versus the last time.
Because they're just intended for the stack, right? And there are cases where during rebase, you actually, as I think Jesse pointed out, you actually do want them to be different. Like if your ESM credentials change, you still want to be able to rebase all your ESM using images, and you need to provide different credentials on the rebase. Because they're a separate set of environment variables, you can make a contract now, because they're not mixed with the other build pack environment variables that say these things can't be things that when they change affect the ABI compatibility of the base image, right? We've cordoned it off and now it's safe, I think.
I see.
And then we don't have to put secrets in the image, which would be terrible, right? We couldn't do that really.
I like that. That's kind of what I was envisioning with Joe mentioning it earlier, but I do think having the contract and making them very explicit, like these are, you should provide these during rebase.
Okay, so we're 2 minutes over, but we came up with a problem, which is configuration, and we think we have a solution that nobody has said they hate so far. That is separate set of environment variables for stack packs that are provided through the platform M directory, as Joe suggested, with an alternate platform directory.
Yeah, with a very specific contract, right?
Yes. Pack
The contract
dash,
up to the stack author. It's just explicitly not the other directory. And that's really the important part, right? That someone else controls. It's not.
Yeah, am I muted? I'll take a stab at writing that up.
and then I know we're over. Is there anything else in stack packs? I want to still very invested in getting something that we can get approvals on as soon as we can. Is there anything else that folks should look at? Any other problems we've identified? I know last time we were talking about like the different phases and how there might be some issue.
Yeah,
with,
the
Run image mixins, when do we get them? I think is a big one. I'm wondering if we actually need to run analyze before detect and pass the run image to analyze and write down the mixins.
or another phase that pulls it off the run image. That seems like maybe it's solvable.
Yeah, I didn't follow that. Is that the same as? I can point out some things that are in the RC that I think are open questions. Is that what this is? What happens if the mixins change at some?
I think it's.
I know you said
detect has to know the run image mixins, and so it's figuring out how that happens. I think is still up in the air.
I should kind of like the idea of putting analyze before detect because there are a couple things that'd be nice to check up front anyways. Like what's the stack ID of the previous image and can we connect to everything? And then if analyze, could resolve the run image reference into a digest reference, then you're getting the same thing later, like we do the previous image in analyze and then in export. It could work out nicely.
okay. So the sections that I think are going to be, I read over everything before the meeting to prep for us reading over the thing that we didn't do. But the sections that I think need to be addressed are certainly this part. I think that's actually on me to spell it out. We went through these other sections. This is where we finished off, and I'm not sure if we were aligned on how the build packs in binary are provided to the rebase operation. So think about that. I'll try to think of an alternative example for CA certs for non-mixin build plan dependencies. And then there's a few open questions, like I mentioned, what happens if the mixins change?
Is there any concern with storing the build plan in a label? Like, are there ever any secrets in there? Like for downstream build pack authors, is there any?
Sort of by default, it gets turned into a label anyways, like the bill of materials, the way we do things now. So I think it's already assumed to not be secret.
Build pack does have a chance of filtering the build pack plan before it ends up in the bill of materials, but I don't think that implies that the build pack plan is a secret. So I think I agree. I got to drop. Thanks, everybody. Sorry, Joe, that we didn't get to do the readout part, but
okay.
Wednesday. Can we do Wednesday?